Hello everyone, welcome to my YouTube channel. It's Max, and today we're going to kick off a video series about how to make your own crypto application. I hope the title didn't clickbait you too much, as this is actually a video series on how to make your own crypto application. It just has nothing to do with cryptocurrency or blockchain or anything like that. So if you're trying to mine a million of your favorite dog-themed coin or anything like that, this isn't the video series for you. But with that said, let's jump into the video. Here's a rough sketch of what I want to build over this video series. It's a simple application that's used to encrypt and decrypt messages. And the application consists of two main components. First, there's this encryption tab, and this is going to be where we encrypt and decrypt messages that we're sending with whoever we're talking to. And then the second tab is called key exchange. So the encryption is going to have a certain configuration that both people who are exchanging messages are going to have to sync up in order for them to encrypt and decrypt messages properly. And we need a secure way to send that configuration information, and that's what this key exchange feature is going to be used for. And if any of this isn't really making much sense right now, don't worry. As we go through the video series and start building the app, we'll dive deeper into these concepts and things will start to make more sense. Here's a roadmap for what the video series is going to look like. So we're going to break it up into four main sections. The first section is going to be about the theory of operation behind the Enigma machine. So the Enigma machine is what we're going to use to encrypt and decrypt our messages for the application. The second part of the series is going to focus on actually implementing the Enigma machine in software. So writing the code for encryption and decryption, as well as designing the user interface for the application. In the third part, we'll discuss the diffie-hellman key exchange. This is how we'll securely send the app's configuration information between users. And in the last part of the video series, we'll talk about coding up the diffie-hellman key exchange, specifically the key exchange protocol and the user interface. Even though the roadmap has four main sections, that doesn't necessarily mean the video series will be just 4 videos long. Depending on how long some of these programming videos take, we might split up the actual encryption protocol coding and the user interface design to separate videos. Okay, now that all that stuff's out of the way, let's jump into the first section of the video series and discuss what an Enigma machine is and how it works. Okay, so first, let's talk about what an Enigma machine is. So an Enigma machine is a very old electromechanical device made by the Nazis in World War II to secretly send messages. Disclaimer, not a fan of Nazis, but this is a pretty cool machine. Here's a picture of an Enigma machine. And how this would work is, if you guys can see, there's sort of two sets of letters. This first row of letters is just like a traditional keyboard. You can just press these buttons like normal. And then there's a corresponding set of light bulbs with letters inside of them. So basically what you would do is you would press a button on this keyboard, and that would be the plain text you want to encrypt, and then the encrypted version of that letter would be whichever light bulb lights up. So for example, you might press the letter Z right here, and then the letter H light bulb might light up, and that means Z would get encrypted to H. There's two more elements I'd like to highlight in this picture. The first are these 3 metal wheels right here. These are called rotors, and the rotors control how the wiring is set up between the light bulbs in the encrypted text is connected to the keyboard buttons in the front. And then the second element I want to discuss is what's this sort of jumbled mess of wires down here, and this is called the plug board. This is an additional set of ways to jumble up the letters and encrypt them that can be used. And basically, you can sort of move these plugs around to add an additional set of swapping between 2 letters. Here's a simplified diagram of what an Enigma machine looks like. So let's walk through how the encryption would actually work. So suppose we want to encrypt the letter A. The letter A would come into the Enigma machine and pass through the first rotor. So let's assume the first rotor is this one on the left. The outer letters represent the input to the rotor, and then the output is denoted by these red letters in the inner circle. So if we passed in a letter A would go through the first rotor and then get mapped to X. This X would then get passed to the second rotor and then get mapped to a U. This U would then get passed to the third rotor and get mapped to a J. Then the J would go to the plug board. So in the plug board, J gets mapped to P. And then this process would be applied in reverse. So then P would get passed backwards through the 3 rotors. So P would then become, where's P? P would then turn into an O. Then the O would go get fed backwards to the second rotor, and then O would get mapped to D, and then D would get fed backwards through the first rotor and then get mapped to G. So in this case, if we input the letter A into the Enigma machine with this set of rotors, a G would come out as the encrypted letter. So at this point you might be asking yourself, why do we need 3 rotors? I mean, at the end of the day, all we did was input an A and output a G. Couldn't you do the same thing with just 1 rotor? And also, with what I just showed you, if you put in 2 A's, you'd get out 2 G's. So you would, like, if you had any example of what the plain text looked like, you could easily figure out that, okay, now A maps to G. And then if you had any more examples of plain text and the encrypted text, you could easily break this system. So what's very clever about this system is that, and I didn't show you this in the first example, every time a letter passes through this process of going through the 3 rotors, going through the plug board, and then back out the 3 rotors, afterwards, one of these rotors will actually rotate. So you can imagine this inner set of red letters would rotate 1 position. So every time a letter gets passed through, this inner set of letters would rotate 1 position. And so what that would result in is, for example, if we put in the letter A twice, we would actually get 2 different ciphertext letters out. And then once this once these inner letters get rotated all the way around once, then the second rotor would get moved 1 position. And then once this rotor is rotated all the way around once, this last rotor would get rotated around 1 position. And so on. So it's kind of like hands of a clock. Like, this is sort of like the fast rotor, and then once this one goes all the way around, this middle one would turn 1 position like a minute hand. Then once the minute hand sort of goes all the way around, the hour hand would turn 1 position. And this way, you can input the same letter multiple times in a row, and you get a completely random string of text out. Okay, enough of me talking about it. Let's actually watch an animation of how we would encrypt the word hello. So here we're feeding in an H to the machine, and it's going through the 3 rotors, going through the plug board, and then in the reverse direction through the 3 rotors. Now here, watch the left rotor. The left rotor just rotated 1 position. Now we're passing an E through. It looks like E is getting mapped to C. Left rotor rotates 1 position again. And now here's the cool part of the Enigma machine being illustrated. So L just got mapped to K, but since that inner set of letters is rotating, the next L will not get mapped to a K. And here's the last part, encrypting the O. And let's see. And there we have it. It looks like the last letter, the O, got encrypted to an O again. And so this is actually kind of funny. So it looks like H got mapped to H, E got mapped to C, the 2 L's got mapped to K and M respectively, and the last O got mapped to an O. One thing that's kind of interesting to point out is that one of the flaws in the original Enigma machine was that I'm pretty sure it was configured such that no letter could ever map to itself. So with the implementation I have here, that's obviously not true. This is just a coincidence with how I made these rotors, but the H mapped to itself and the O mapped to itself. Now that we know how to encrypt text with the Enigma machine, the last thing we need to understand is, well, how do we decrypt text? And for that, the answer is super easy. We actually just do the same thing. So all we need to do to decrypt this text, this HCKMO, is to pass it through the Enigma machine with the rotors in the exact same starting positions they were when we first encrypted hello. So let's look at what that would look like. So this first part of the animation is just sort of building the Enigma machine. And right now the rotors are in the exact same configuration they were when we encrypted hello. So now we're feeding in the ciphertext from the last animation to the Enigma machine. and we just put in an H, and if everything works correctly, we should get an H out. And we do. And again, the rotors are still making that one turn every time a letter gets fed in. Or, sorry, the left rotor is making that one turn every time a letter gets fed in. Then we just fed in the C, and it looks like the C is getting mapped to E, which again is correct. Feeding in the K. Oh, and sometimes in the literature you'll see so that blue rectangle with the letters in it, I first introduced as a plug board. Sometimes in certain articles they'll call that a reflector as well. Here the second, or the M is getting passed through, and again we're getting the L, which is awesome, just what we wanted. And finally we're putting the final letter, which is the O, and we should hope to get an O out. And there you have it. We successfully encrypted the word hello and then decrypted it with the Enigma machine in the same configuration. That's the main concept about how an Enigma machine works. And this is going to be the exact method we use in our application to encrypt and decrypt the messages we want to send. If you actually want to see how to code this up, stay tuned for the next video in the series. Right now, I'm not exactly sure what programming language I want to use. I'm thinking about either Python or C#. So if you guys have a preference, please let me know in the comments below. And that's the end of the video. So if you liked it, please like, comment, and subscribe. And I'll see you next time. Bye.